Well, I hope you didn't think I forgot about you, because I didn't. I just actually forgot my iPad at school, so I had to get it home. So today I'm going to talk to you about systems of equations, and we are going to focus on the addition method, which I think you're going to really like. Last week we talked about the substitution method and the graphing method. Well, the addition method, basically, when you look at your system of equations, what you want to ask yourself is, could I add these two equations in such a way that I no longer have two variables? Instead, I just have one variable. Well, this problem is set up really nice for us because look, if we add a negative y and a positive y, that will make a 0, which is exactly what I want. I want one of the variables to eliminate. So 5x plus 3x is 8x, and we know negative y plus y is 0, and 12 plus 4 is 16. So now we divide both sides by 8, and we get x equals 2. So you're saying, Miss Kleiber, why did you just not show us this in the beginning? Well, this problem was just set up really well for this method. Now, always remember, though, when it's a systems of equations problem, we have two variables. So we just solved for the first variable. So I'm going to take that first variable, x equals 2, and plug it back into one of the equations. I'm going to use 5x minus y. So wherever there's an x, I'm going to replace it with 2. So now I have 5 times 2 minus y equals 12. So it's 10 minus y equals 12. So my goal is to get y by itself. So I must subtract 10 first. So I subtract 10 from both sides. And now I have negative y equals 2. Well, I don't want to solve for negative y. I want to solve for positive y. So in essence, that is a negative 1 times y. So I'm going to divide by negative 1, but we know if we divide one side by negative 1, I have to divide the other. So a negative divided by a negative is a positive y equals negative 2. So my point where they, if I graphed them, intersect would be 2, negative 2. Now, I forgot to say at the beginning of this video that you need to write down all of these examples. So if you did not write this down, I want you to stop the video, replay it, and write it down because I'm going to ask to see your notes. This is, in order for you to be able to do a retake, there's got to be some work involved, and I want to see these notes. Okay, let's move on to the next problem. Okay, so now we have 6c plus 7d equals negative 15. And we have 6c minus 2d equals 12. So the goal is that when we add two equations together, at least one of the variables will eliminate. Well, if I add these two together, I'd get 12c. So that doesn't eliminate. And if I add 7d and negative 2d, I get 5d. So that doesn't eliminate. So remember, in order for them to eliminate, they need to be opposites. Well, these are super close, aren't they? Just if one of those was a negative 6c, then it would work. So you know what I'm going to do is I'm going to multiply the lower one. Now you could do either one by a negative 1. And of course you know if you multiply one part by a negative 1, you have to multiply every part by a negative 1. Now I like with the addition method is to write the problem down, and then I like to see how I kind of drew the arrow. Now I'm going to multiply by a negative. So I have negative 6c. And then a negative 2d, right, we're going to do the distributive method. Negative 2d times a negative 1 is a positive 2d equals, and then a negative times a 12 is a negative 12. Now the first equation didn't change, so I'm going to rewrite the first equation. So do you notice how I'm setting this problem up? I'm setting it up for success. That's what I'm doing. So I want you to set yours up correctly also. Now when I add these two together, we see that a 6c and a negative 6c make 0. And 7d plus 2d is 9d, not 90, but 9d. And then negative 15 and negative 12 is negative 27. So now I divide both sides by 9 because I want to isolate the variable. So d is equal to negative 3. Fantastic. But as we said in the first problem, that once we solve for one variable, we have to plug it into one of the other equations. And it really doesn't matter which one. I don't know. I'm going to pick the second one this time because I picked the first one the first time. You can do whichever one you like. So wherever there's a d, I'm going to replace it with a negative 3. So I have 6c minus 2 times d. Well, D is negative 3 equals 12. So I have 6C, and we know a negative times a negative is a positive 6. Now remember, our goal is to get C by itself. So I'm going to subtract 6 from both sides. Notice how I'm showing the work, spacing it out, right, Nick? Not squishing, equals 6. So C would equal 1. So my solution would be 1, negative 3. Fantastic. Okay, now here we're doing one that's a little more challenging. And the reason why I say it's more challenging is because if I were to add these two, notice 4x plus 3x is 7x. Okay, they're not opposites. Negative 5y and 10y is 5y. They're not opposites. So I have to create opposites. So look at the x's, 4x and 3x. What could 4x and 3x go into so they'd be opposites? Well, they could both go into 12. So I could make one a positive 12 and one a negative 12. Okay. What about the y's? Well, negative 5 and positive 10, well, they could both go into 10, right? And so if I multiply the first equation by 2, that would make a negative 10y in the first equation. And if I multiply, actually, I don't have to multiply the second equation by anything because it's a positive 10, right? I'd get a negative 10 in the first equation. So 8x, notice how I'm setting it up again, you guys. Make sure that your setup is nice and neat. Minus 10y, and then equals 46. Now sometimes you will have to multiply both equations by something, but in this example, I didn't have to, because now I have opposites. So now I add them together, so I get 11x equals, and I add that together and I get 77. Well, this is going to work out nice, isn't it? So when I divide by 11 on both sides, I end up with x equals 7. And you know the drill. Go back to the original, and I'm going to pick 3x plus 10y equals 31, and I'm going to substitute x for 7. So 3 times 7 plus 10y equals 31. So now I have 21 plus 10y. Wow, this is going to work out nice, isn't it? And now I subtract 21 from both sides. So now I have 10y equals 10. Woohoo! Y equals 1. There we go. Now you try 1 by yourself, and then we'll see how you did. So here's the last problem. 3a plus 4b equals 2. 5a plus 9b equals 1. Pause the video and try it by yourself first. Okay, did you really pause the video? Because I want to see your work. When you show me your 4 problems, I want to see your attempt first. So if you didn't really try it, pause it now and try it. Okay, here we go. Now, when I look at this problem, I notice I have a 3a and a 5a. So those two numbers would go into 15. I can make one a positive 15a and one a negative 15a. 4 and 9 both go into, 36. I think 36 is the smallest. So one could be positive 36, one could be negative 36. You know what? I think I'm going to go with the 15a's because it's just a smaller number. So I want one to be a positive 15a and one to be negative. So I'll make the first one negative. So I'm going to multiply by a negative 5. Now remember, I have to multiply every part by a negative 5. So I end up with negative 15a minus 20b equals negative 10. Don't forget to distribute. Now I want this to be a positive 15a, so I'm going to multiply everything by a 3. So I get 15a plus 27b equals 3. Okay, now I'm going to add them together, and of course the a's make a 0. That's what I wanted. Oops, I forgot my b here. Oops, lo siento. Okay, so negative 20b plus 27b is 7b. Negative 10 plus 3 is negative 7. Oh, beauty. Divide both sides by 7. B equals negative 1. Nicely done, Miss Kleiber, if I do say so myself. Okay, now let's find A. So 5 times A plus 9B equals 1. So wherever there's a B, I will put a negative 1. 9 times negative 1 equals 1. 5A minus 9 equals 1. Great. So now my goal is to get A by itself. So I'm going to add 9 to both sides. So 5a equals 10. Divide both sides by 5. A equals 2. Now, is that what you got when you tried it on your own? If not, make corrections in colored ink so I can see it, and bring this piece of paper to me on Monday on A5B when you're coming for your retest. And make sure all of your homework's done and completed. See you guys later. You did a great job this last week. Bye-bye.